Hello and welcome to the update from the testnet team. Let's get directly into your Q&A questions. These next questions are going to be from Andrew. Thank you so much, Andrew. Learning a lot. I just want to say we have to get some community rewards over to you. So those are coming. Is it correct to say that Tao's intended behavior defines what is good, while its prohibited behavior defines what is bad? And the next question, does better or worse refer to looking toward the future and enabling evolution, while still remaining aligned with previously established guidelines and principles?
Thank you for the question. Um, so in the realms of logic, it's not really definable what good or bad means, since this is something philosophical in the end. So instead, I think it would be better if you say that intended behavior defines just what happens, and prohibited behavior defines what does not happen. I mean, that sounds like a triviality, but that is what it is in the end, and I don't think it makes it easier to obscure the concept of what defined behavior is and what prohibited behavior is.
Yeah, so in addition to Luca's answer, I will say that a goal for a much later stage of the system when we can support much broader logical frameworks than only the Tau language. And in those broader logical frameworks, people will be able to say something about good and bad and better or worse. No one can accurately define what is good and bad and better or worse. And of course, even if yes, there is not one definition, but in a much richer logical frameworks, which I hope we will have in the future, we will be able to say something. And then hopefully the system will be able to converge to admit those things that people to become good according to constraints that people put. What does it mean to be good and better or bad and worse?
What does it mean for a formula to be satisfiable but invalid? Over to you, Luca.
Thank you for the question. Um, so a formula satisfiable if you can find substitutions for the free variables such that after replacing the formula is equivalent to true, meaning that you found an assignment to the variables that make us satisfiable. Hence the naming. Invalid, on the other hand, is not really a notion that is used within logic, I think. I think the notion usually used is unsatisfiable. So unsatisfiable means that there's no assignment that makes a formula true. And maybe the confusion comes from the term valid, because a formula is valid if all possible assignments make a formula true. Yeah, and the opposite of valid, as I said, is unsatisfiable. So perhaps that's the better term. But in conclusion, there's no formula that can be satisfiable and unsatisfiable at the same time in any sound logical system.
And the next question. Bounded lookback, a unique feature of Tau, allows referencing any point in the past. In contrast, finite state machines rely only on the current state and input to determine the next state and or output. Is that correct?
Well, not exactly. So bounded means that you cannot look at any point in the past. You can only look a fixed number of points which you specify in the program, 1, 2, 3, 4, 5, a certain number. You cannot look all the way to the past. In finite state machines, they can be simulated into another finite state machine that also have a bounded lookback. But this procedure breaks down once you have an infinite domain. So in Tau, we can do that even if we have an infinite domain.
And the next question, could you explain how the this function is a special stream that plays a specific role in Tau's pointwise revision mechanism? Please provide more example demonstrations. What does it mean for a formula to be valid or invalid?
Thank you for this question as well. So the this input stream basically acts like any input stream on the surface, meaning in the check whether the formula is realizable, this input stream is quantified as for all. So that means whatever is written into the this stream, the formula needs to be realizable. Um, The special characteristic of the stream is that because it is universal, it can't be used to basically add assumptions to the formula. And this general idea enables us to write the current specification into the stream by hand, because this stream allows any input. What we input in each step during execution is the currently running specification. And we added this feature in order to be able to extract the currently running specification into, for example, an output stream. If you assign this input stream to some output stream, for example, you can print the currently running specification. Yeah, thank you.
What is the current progress of the stress testing on the Tau interpreter?
Basically, we don't necessarily have a separate process for stress testing the interpreter, as pretty much every test we do constitutes a stress test for the Tau interpreter and pushes the performance limits. Basically, most of everything we do does that. And as we'll see in the update section coming up next, is that we're always working on improving the performance of the Tau interpreter. So I hope that answers your question.
Why is quantifier elimination important for a given expression, and what are the benefits?
The property of a logic admitting a quantifier elimination procedure in general is important if you want to transform a non-closed formula that has certain quantifiers into a quantifier-free formula. If the logic does not admit a quantifier elimination procedure, this is not possible. For our purpose of checking realizability of a formula, of a specification, we quantify the formula fully in order to decide if it is realizable or not. So for this check, a complete or a quantifier elimination process would not necessarily be needed, but we could also rely on an algorithm that is able to solve or to resolve quantifiers on a closed formula. However, when we convert our specification into the form that the interpreter can run without a quantifier elimination procedure, we would have quantifiers in this expression. Currently, if we have certain formulas, we are able to completely eliminate them to give a streamlined quantifier-free unbounded continuation. This is the formula the interpreter runs. But in the future, with bit vectors enabled, for example, this will not always be possible. So for this reason, the unbounded continuation can also contain the quantifiers, and then whenever the step for solving for the outputs is invoked, the formula will be closed in order to do that. And at this point, we can then solve it. Yeah, that is the basic overview of what we most crucially use the quantifier elimination algorithm for at the moment.
And the next question is, how is reactive synthesis different from software synthesis?
To be honest, I didn't know exactly what reactive synthesis was until I looked it up. And it's very much like software synthesis, where you're generating a program based on a formal specification, except that the program is called the reactive program, which means that it's intended to be always running and reacting to inputs in its environment. I think that's the difference that I found.
And the next question is from Charles. Why does Tau currently receive limited attention with few views on posts on X and Reddit? Are there plans to increase publicity?
Yes, thanks for your question. So, yes, increasing visibility is something we're actively working on. We've been publishing more content, as you can see with the 2 articles that we've published past month. We've been reaching out to agencies and preparing for a broader push as we move closer to testnet alpha. And yeah, we're also exploring on how to better use social media. We recently had a call with Reddit to look into advertising options, and we're in discussions with potential partners and agencies who may be able to help us create high quality content about Tau, especially on platforms like YouTube, because video is still the best converting medium. So yeah, there's a lot that we're working on. Thank you.
All right, we're back in Andrew's questions now. And he asks, can a quantifier like always be revised in the future using pointwise revision?
So the an always statement in the specification basically specifies what should be the case in each step. Now, if you specify something that, for example, should happen once, so using the sometimes, and this contradicts the always statement, then what pointwise revision will do is to update the specification with the sometimes statement, because that is the update basically. And so in this fashion, you can update always statements to sometimes statements, for example. And yeah, I think this answers the question.
And the next question. Inadequate rules could have serious consequences for network security and integrity. Could you give us some simple safety guidelines to carefully test and draft rules?
One way is to define what is something bad that you don't want to happen. And then in the specification, you can say that this should never happen. And that's something that you cannot do in programming languages, in programming languages, but you can do in the Tau language.
All right, and the last question. Will we be able to query the opinion map on the production-ready testnet expected next year?
It's a bit early to speak about it and to speculate about it, but since you have on your node all transactions on the blockchain with their respected rules, you can build queries under any perspective, including building opinion maps. Of course, nobody stops you from doing that technically.
All right, fantastic. That about wraps it up for our Q&A for September. Thank you so much, Andrew, for carrying this Q&A. It's a lot of excellent questions there. Excellent question from you as well, Charles. Thank you so much for asking that as well. So yeah, we will see you on our socials. As always, on X, it's Tau_net. On Reddit, it's TauNet, Agrs. And on Telegram, that's TauNet.